Each year, craft-related issues are responsible for over 1.3 million service calls. The impact to the customer experience and financial costs is tremendous. In this series, we will use specialized test equipment to demonstrate the impact of common installation errors on the DirecTV signal as it travels through the home network. Okay, so this is something else that we all ran into at one time, the unapproved wall plate. This is where it's got the barrel that's clear or white. What happens is, in the MoCA network, as you can see here, the signal loss is very small. However, it has a lot of high reflections. What that means is you're going to have signal loss, poor signal performance, especially in the MoCA network. You're going to get no video audio data packets. You're going to get poor connectivity to your MoCA connected devices, and your swim performance is going to suffer. So again, make sure you check all your connections, make sure you check all your wall plates, and make sure that the barrels in the wall plates are DirecTV approved. Now for this demo, we're going to talk about splitters. So the first one I'm going to show you is the DirecTV approved splitter. Also, you'll notice I have a terminator like they all should be. As you can see, it's pretty flat, which means there's not a lot of loss. Two-way splitters typically will have anywhere from 3.5 to 4 dB loss. And if you look at the return loss or the reflections, you can also see it's pretty flat and it's pretty low, which is ideal, where you want it to be. Now what I'm going to do is take the terminator off and look at what it does to the signal. So now you can see we actually have some signal loss, and this right here is in the MoCA band. So right away we're going to have degraded performance for the MoCA circuit, which means that you're also going to have some possible MoCA issues. But what's most interesting is now we've got reflections. We're getting reflections from this open port not being terminated, and as you can see here, the performance is now being degraded, which means also the MoCA performance is going to be degraded. Okay, so I just showed you the DirecTV approved splitter. Now I'm going to show you what it looks like with a unapproved splitter. As you can see, for the most part, it looks very similar. However, right here, this is the killer. This thing is dropping out right in the middle of the swim frequencies. What that means is you're going to have very low signal getting through to the satellite box. Also, the return loss is very high on this device. What you don't see is at this end, the 2.4 megahertz, 2.3 megahertz, down in that range, this splitter rolls off at 5 megahertz. As we get down to the lower end, it's going to have an issue with the swim communication at the 2.3 megahertz. So besides having the satellite issues, you're going to have swim communication problems. Not good, because you'll probably be getting 775 and some other issues when you use these. So when you do an install, make sure that you get all these splitters out of the network and only use DirecTV approved splitters. What I've got here, I've got two decas, and I have to attenuate it because the signal from the decas is very powerful. But what I'm showing here is I'm going through a four-way splitter. You can see that the decas have synced up, but also I'm connected to a spectrum analyzer. And what you can see here, these are the decas talking to each other. So what I'm going to do, I'm going to open up one of the ports and I'm going to introduce some ingress. So as we have ingress, you can see what happened was the MoCA signal got lost. We now have a carrier on top of the MoCA band, and now the decas are struggling to communicate with each other. Again, if this was properly terminated, we wouldn't have this issue. But this is what happens when we leave splitter ports unterminated. We hope that today's demonstration of signal impacts will help you understand the importance of performing each step of the installation process properly and with care. With your help, hundreds of thousands of service calls can be eliminated each year and the customer experience improved dramatically. I'm Dave Keither. Thank you for your time.
Confused about 4K? You know, what hardware goes with what 4K package? How is each 4K service delivered? What 4K content are we currently offering?
What channel do I tune to verify 4K programming?
What's the strategy with the digital reverse band LMBs? Welcome to 4K in 4 minutes, where we endeavor to answer your 4K questions in 240 seconds. Well, some of them. Ready? If the customer has an HR34, HR44, or H44 with a hard drive installed and a C61K or DirecTV 4K Ready TV, regardless of the package they subscribe to, they have access to 4K VOD only on channel 1104. If the customer has an HR54 Genie installed with a C61K or DirecTV 4K Ready TV
and subscribes to the Select or higher package,
they have access to 4K VOD on channel 1104, 24/7 4K live and curated content on channel 104, 4K pay-per-view movies on channel 105, and both free and pay-per-view events in 4K on channel 106. 4K VOD is delivered via satellite or broadband. Some of the differences are: when 4K content is delivered via satellite, the program info screen will state the time and date the program will be available if recorded. Customers will know it's viewable as soon as it shows up in their playlist. When 4K content is delivered via broadband, the program info screen will allow the customer to play the content immediately, depending upon the broadband speed. The customer may want to be mindful of bandwidth caps. 4K broadcast channels are delivered via satellite and feature live and curated programming. They play instantly via guide or channel change. An HR54 is required as a pass-through to view this content on a 4K client. The reverse band should only be installed when indicated on the work order and in service situations which are like for like. During our first phase of 4K broadcast delivery, content is being delivered via AA band. That means any SWIM LMB or SWIM module can deliver 4K content. The inclusion of the reverse band LMB is a proactive future-proofing measure to help minimize future truck rolls when the digital reverse band LMB becomes a technical requirement. Don't worry, plans are in the works to ensure we have enough time to upgrade all 4K customers who do not have a reverse band LMB prior to switching over to using the reverse band technology to deliver the 4K content. These plans will include how we will accommodate our customers in Alaska and Hawaii and those with international programming. Hopefully this answered some of your burning questions concerning 4K. We'll be back soon to answer a few more. In the meantime, search the doc, keyword 4K.
Here's how to align and peak a slimline SWIM LMB using the AIM. The tools that you will need for aligning and peaking the ODU are your AIM, half-inch nut driver and half-inch box wrench, or ratchet and sockets. After you've assembled and installed the ODU according to DirecTV procedures, connect the AIM's ODU-F connector to the ODU's LMB output. Turn the meter on. When you're at the home screen, press Setup to display the Modified Job Setup screen. This is where the account number, notes, ODU, switch type, and zip code can be modified. The settings are already correct for this installation, so we'll go ahead and press Install. Verify that your ODU's tilt and elevation settings match the settings that are displayed on the Pre-Configure ODU screen. Press Next on the pre-configure ODU screen. You'll now be able to perform the course alignment for azimuth and elevation. Here's how. While monitoring the signal on the course azimuth and elevation adjustment screen, slowly rotate the ODU on the mast to the left and right until you have reached the maximum signal. Keep in mind that all LMBs are different. Some will peak around -30, while others will peak around -25. Once you've reached maximum signal level, lock down the mounting bracket collar on the mast. You will now use the fine adjustment screws for azimuth and elevation to course align the ODU. First, loosen the ODU's 2 elevation screws and 1 azimuth lockdown screw. While monitoring the signal power bar on the course azimuth and elevation adjustment screen, rotate the elevation adjustment screw one direction until you've passed peak. Then reverse your rotation to bring signal back up to peak. Next, hit clear peak on the meter. Then complete the same procedure to course align the azimuth using the azimuth screw. In some cases, you will need to alternate between the course elevation adjustment and course azimuth adjustment to get the maximum signal strength. Once you've achieved maximum signal, tighten the elevation and azimuth lockdown screws, then press next on the aim to continue. Loosen the ODU's tilt lockdown screws while monitoring the DBM bar on the tilt adjustment screen. Because we are working with a Slimline 5S LMB, we need to perform the tilt adjustment. If we were working with the Slimline 3 LMB, the tilt would already be set and does not need to be adjusted. Slowly rotate the ODU around the tilt axis until the maximum dB value is reached. Tighten the tilt lockdown screws, then press next to continue, and that completes the course alignment phase. To perform the fine elevation adjustment for an SL5S, loosen the elevation lockdown screws. Zero the elevation dial. Then turn the ODU's elevation adjustment screw counterclockwise 2 turns. Press Set Ref to set the reference value. The aim sounds a confirmation tone and displays the reference value. Now turn the elevation adjustment screw clockwise while counting the turns and fractions of a turn. Continue turning until the meter stops beeping and a confirmation tone is heard. The meter will display a pop-up asking you to enter the number of turns and fractions of a turn. Double check that the signal power matches the reference value. Then enter the number of turns and fractions using the meter keypad. Press OK, and the meter will divide the number of turns and fractions of a turn in half. Set the dial to 0 and turn the elevation adjustment screw the number of turns displayed in the pop-up screen. Press OK, and the peaking of the elevation is now complete. Now tighten the elevation lockdown screws. Press Next. We'll complete the same peaking steps on the azimuth adjustment screw. Loosen the azimuth lockdown screw. Zero the azimuth dial, then turn the ODU's azimuth adjustment screw counterclockwise 2 turns. A full turn is indicated by 1 full turn of the dial from 0 to 0. On the fine azimuth adjustment screen, press Set Ref to set the reference value. The aim sounds a confirmation tone and displays the reference value. Now turn the azimuth adjustment screw clockwise while counting the turns and fractions of a turn. In some cases, the meter will ask you for another turn when peaking. This means you are not far enough down from the peak. When the meter begins to sound a series of beeps, slow down. This indicates the reference value is within 1 dB. Continue turning and counting the fractions of a turn until the meter stops beeping and a confirmation tone is heard. The meter will display a pop-up asking you to enter the number of turns and fractions of a turn. Double check that the signal power matches the reference value, Then enter the number of turns and fractions using the meter keypad. Zero out the readout dial on the azimuth adjustment screw. Turn the azimuth adjustment screw counterclockwise the divided number of turns. Press OK, and the peaking azimuth is now complete. Now tighten the azimuth lockdown screw, then press Next. Finally, run EIV to verify that all signals are within the acceptable thresholds for the zip code you are working in. If you do not pass EIV, check all cables and connections between the meter and the LMB and repeat the aligning and peaking process. For more videos and information about the aligning and peaking process, search the doc using keyword AIM.